7.2. This is solving equations using addition or subtraction. And I'm going to try the notes this way this time. So up at the top, I want you to put, let me get my pointer out here. Come on. There we go. So 7.2 lesson. What I want you to start off with is writing out this statement. It says equations may be true for some values and false for others. A solution, okay, of an equation is a value that makes the equation true. So I want you to look at this table here. We start off with this column, and I want you to draw this all out. So pause it here, and you can write this out, and then write as I go. And then you can hit play again. So the value of x. They're telling me that the value of x for this row is 3. The value of x for this row, oh, that's a terrible arrow. There we go, is 4. And the value for x for this row is 5. So be really careful that this part becomes very confusing. Doesn't need to be though. Here's our equation that we're working with. X plus 3 equals 7. So we know that the value of x over here is what they told us, 3, 4, and 5. So let's plug it in here. You're going to hear me talk about plugging in numbers like crazy now because of we're balancing equations, okay? We're solving these actual variables now. We talked a lot about variables in other chapters, but now we're actually doing the solving portion of it. So now I have 3 because that used to be x. So right here is where it was x. Now it's 3. So 3 plus 3, what they're telling us is that it equals 7. Well, we know that 3 plus 3 actually equals 6. So we balance this side out. We get 6. And then we recognize that it does not equal 7. So they're asking, are both sides equal? And our answer for that is no. So if you can follow this table to kind of give you an idea, we plug a number in, we see if it makes sense. So 4 plus 3 equals 7 on this side. We're balancing this equation. They're telling us it's already 7, so does 7 equal 7? Yes. Same thing over here. Now we plugged in our 5. 5 plus 3 equals 8. 8 does not equal 7, so no is our answer. Okay? So we know that the value x equals 4 is a solution of the equation x plus 3 equals 7. Now, I want you to just think about this for a moment, okay? We've got this equation, x plus 3 equals 7. I think all of us should be able to say we know 4 plus 3 equals 7, and we can fill it in. This, obviously, like I always say, things get harder, so this is a good example of how we can balance them to make them both sides of the equation the same, okay? Okay, so this next part of what we're going to do is learning about inverse operations and how we can actually solve the equations. So I want you to copy this down. It says inverse operations. They undo each other. So addition and subtraction are inverse operations. So we know that if we have 8 of something and we take away 8 of something, then it's gone. And that's what basically they want you to understand about an inverse operation in this section. So we're going to do the key ideas. I'm going to have a picture for you, and I'm going to go over those properties because they're really important of how they eliminate each other. Okay, so we're going to start with the addition property of equality. And what it means is when you add the same number to each side of an equation, the two sides remain equal. And obviously a key word here that we can show is the word add. That's why it's the addition property of equality. So I want you to look at the examples here. So we have, now, let me get my pointer. 8 equals 8, okay? Pretty simple. If I take and I add 5 to this side of the equation, so we're kind of splitting up this equation, kind of like this, okay? We have 8 on each side. But if we add 5 to that side, and And I have to do the same thing over to this side. It's kind of like a fraction. Remember, if you multiply the numerator by 2, you have to multiply the denominator by 2 to make an equivalent fraction. It's kind of the same thing. If I add 5 over here, I have to add it over here. Now I've just balanced it back out, and I have 13 equals 13. Pretty simple. Now let's go over and look at the algebra side of things. Here's one side, here's one side of my equation. Here's my other. Okay, so we're balancing this out. Let me get my pointer. So if I have x minus 4, it equals 5. I have to figure out what number x equals to get me to 5. Okay, so to balance that out, what I do is I have minus 4. If I add 4, so if I have minus 4 plus 4, that gives me what? Nothing. Gives me x, which is all I have left over here. So if I'm going to put the 4 over here and add it on this side, I'm going to add it on this side. So 5 plus 4 equals 9. Why did I choose 4? Well, I chose 4 because that's what this number was. You're not going to add 5. That's not going to give me a 0 over here. You're trying to balance this side to be nothing but the variable. And we'll talk about that when we do the practice with it. So this is just the addition property of equality. We know that if we add one number to one side, we have to do it to the other. So it's the same situation when we look at the subtraction property of equality. When you subtract the same number from each side of an equation, the two sides remain equal. Okay, I want you to write all this out if you haven't been. It's good to write these things so that you're seeing them. So let's look at this part, or this side of the equation and this side. All we did here, same thing like up in the top, we subtracted 5 from 8. We subtracted 5 from 8. We did it on both sides of the equation. Why did we pick 5? Just because it was a random number, just to show you that the subtraction property of equality works. If you look, it's comparable to this one because we had 8 equals 8. If we take away 5 from each side, we get 3 equals 3. We kept the balance where we wanted it. When it comes to algebra, it's kind of the same situation. We take away one number from one side, we do the same on the other side. And boys and girls, remember, when I'm talking about sides, I'm talking about what side of the equal sign. Okay, that's what we're trying to balance out. So if I have x plus 4 equals 5, okay, what I need to know is that if I have an addition sign here, I'm going to subtract 4 from it. I'm not going to add it, I'm going to subtract it. That leaves me with x by itself. 5 minus 4 equals 1. So what it's telling me is that x equals 1. Now I want you to think about that. What if I put 1 where that x is? 1 plus 4, it equals 5. So I can balance it out. That's what I'm going to teach you in the next example. Example 2 is solving equations using addition. All right, let's try this one. It says solve x minus 2 equals 6. So I want you to really pay attention to how I set this up, because even next year in 7th grade, this is how they continue to set it up. Your teacher might have a little bit of a different way of doing it, but not very much, okay? So we start off with what our equation is. We have x minus 2 equals 6. So you rewrite that problem, okay? We are trying to balance out the side. So just like we saw in our last little example with the key idea, if I have x minus 2, all I really want to do is get x by itself. We want to know, what does x equal? Okay, that's what we're trying for. Let me erase that. You don't have to write that, sorry. Okay, so in order to do that, I have to get rid of that 2 on this side of the equation. Okay? So in order to do that, I'm going to do the, remember our two properties we just learned. I'm going to do the addition property of equality and add 2 right there. If I have negative 2 plus 2, what does that give me? It leaves me with 0. I'm writing the 0 really tiny because we don't expect you to write that 0. All we know is we have x by itself now. Okay? if I'm going to add 2 on this side of the equation, I have to add it to that side of the equation as well. So I'm going to add 2 over here to that 6. 6 plus 2 gives me 8. So what I have found out is that x in this situation equals 8. We always expect you to do a check to make sure that you're doing it correctly. So your check is very simple. If we had x minus 2 equals 6, all I do is I plug in my new number for x, which is 8, minus 2, does it equal 6? That's our question. Okay? So you do the math. If you get 8 minus 2 equals 6, then yes, it works. Okay, so I'm going to, maybe I could hide, well, I'll just put a square on it. This and this is the type of work that we expect to see on all of these types of problems, okay? The practice that we're going to do today. So you need to have both your check, and I don't call it check, but I put the little check mark here. You need to show me the equation, how you solved it, and then you need to do your check, okay? Let's try another one. So we're going to solve 18 equals x minus 7. And this is similar to what your problems would look like on your practice, like what a homework assignment would look like. It would just basically say solve the equation, check your solution, okay? So that's what we're doing right now. I'm showing you exactly how to do part of your work. So I'm going to write down my equation. 18 equals x minus 7. So this one's on the opposite side. Remember, your goal is to balance both sides, okay, so they equal the same thing. So I'm going to start with where my variable is, and it's on my right side this time. So I need to get rid of any number that is correlated, that's right next to my x, okay, and it's a negative 7 in this case. So again, I'm going to use the addition property of equality to solve this one, because I'm going to add 7 over here to get my 0, which leaves me with just x. That's the goal. Okay. Then, and actually I'm going to redo that one and put it in red to keep with what I'm doing here. Sorry. So I have x equals. Now I have to remember, whatever I did on that side, I have to do over on this side. Well, I added 7 on the right side, so now I'm adding 7 on the left side, okay? And 18 plus 7 gives me 25. Sorry for the wonky writing. And that becomes what x equals. So now I just do a quick check. I rewrite out my original problem. 18 equals x minus 7. And then I just simply fill in what I had. So I had 18, that stays the same. My x, what I'm telling you is that x equals 25, so that's what I'm going to add in over there. So I put in my 25. And I subtract it from the 7 that's over there. Okay, this is still my check. 18, nothing changes with 18. 25 minus 7 gives me 18. So yes, it works. Again, I need to see this and this for one problem. Okay? Example 3 is solving equations using subtraction. So now we're just doing kind of the opposite of what we were doing. Here's an example. Pretty simple. Solve x plus 2 equals 9. So as before, we write out what our problem is. X plus 2 equals 9. Again, we should know the answer in our head to something like this. But it's the process to get there is what I'm teaching you, okay? So a lot of kids want to just skip through the work and be like, I know that answer. Well, guess what? This gets much harder, right? I've told you that a million times. So you have to really take the time to slow down, show your work, and do it correctly, okay? I'll be looking for that in your work this time. All right, so again, we're balancing those sides. I want to get my x all by itself, okay? And in order to do that, I have to figure out, I can use the subtraction property of equality to simplify this by saying I want to get rid of that 2 over there, okay? 2 minus 2 gives me that 0. Again, you don't have to write that 0 down, but what it does is it leaves me with x, okay? On the other side, remember, if I do it to this side of the equation, I have to do it to this side of the equation. Same number, same thing. So I subtract 2 from over here. So 9 minus 2 gives me 7, okay? So now what I'm saying is that x equals 7. So let me do my check. So I'm going to fill everything in. I've got x plus 2 equals 9. So now I'm going to do x. Oops, sorry. I don't want to do x. Erase. So now I want to fill in that x for 7. Okay. So 7 plus 2 equals 9. What is 7 plus 2? It equals 9. So yes, it works. What I want to see on your work is all of this every time. I feel like a broken record. But do it, okay? All right, one more. Okay, we are going to solve 26 equals 11 plus x. So I'm going to start with writing it out. 26 equals 11 plus x. I want to get my x all by itself. So in order to do that, I need to look at what number I have. I have 11. Now, it's a little different because it doesn't have a positive sign or a negative sign before it like the other ones have. We need to remember from the last chapter that anytime we see a number without a positive or negative sign in front of it, it's always what? It's always positive. So I'm still going to use the subtraction property of equality, and I'm going to take away 11 because a positive 11 minus 11 equals 0, which leaves me with my x by itself. Okay? If I do it on my right side over here, I have to do it on this side over here too. So I say 26 minus 11, oops, okay, and 26 minus 11 gives me 15. So my answer is 15 equals x. So we're just going to double check it by putting it over here in my check spot. Plus x, we write it out. We write it out just like that. Now we have 26 equals 11 plus, this time we have 15 to add in the blank. And then we keep our 26 equals 11 plus 15 equals 26. And it checks out. So here's your work, and here's your work. And that is the end of what I'm going to have you do here. Here's a couple practice problems. Okay, try these two out. K minus 3 equals 1. And then n plus 3 equals 13. And then I will put the answer next to them. Here's the first answer. So I have k minus 3 equals 1. I want to get k by itself, so I add 3 to it. Gives me 0, so I keep just my k. I add my 3 on this side, just like I did over here. 1 plus 3 equals 4. So my answer is k equals 4. So now I plug it in. I plugged in 4 for k right here. 4 minus 3 is 1. 1 equals 1. So it checks out. And here's the next one. Okay, so n plus 3 equals 13. You take away your 3 on this side, which gives me n by itself. Take away 3 on this side, it gives me 10. So n equals 10. Over here, I plug in my n. I use 10. 10 plus 3 is 13, so 13 equals 13. And that concludes the video.